blue sheet and worksheet 6. And you have not seen this before unless you took the 1 semester long trig course, okay? These are some weird identities called sum and difference identities. They are not, pardon? Not something you have to memorize. I don't have them memorized by the end of the day. Some days I know them because I've done them so many times, but this is, if you took trig, then you did spend a couple days on these in trig. For this class, we're going to do some applications of them, kind of, sort of, but we're also going to just use the reference sheet, and for a quiz, I need you to be familiar with the reference sheet. All right, this is what they look like. Can you find them on the blue sheet? It says sum relations and difference relations, right? Okay, there was some confusion earlier today when it says, we'll say 30 plus 45. Then 30 is A and 45 is B. If it says 30 minus 45, then 30 is A and 45 is B. It's not negative 45, okay? If you want to call it negative 45, then you have to use A plus B because you're saying that the negative, you're saying it's like plus negative 45. So just use the right formula. If it's a minus, use the difference. If it's a plus, use this one. Does that make sense? All right. The first example I have here, you don't need to do anything about this. Just look up here. It says the sine of 15. We used to have to do these because, well, we still would if we wanted an exact answer, but our calculator does the sine of 15 out to like 15 places, right? But in the past, when you saw the sine of 15, you could use the fact that that's 45 minus 30. And I know the sine of 45 and the cosine and the sine of 30 and the cosine. So I would write out that rule that we just talked about on the sheet, sine times cosine minus sine times cosine. Evaluate those using the unit circle, and you'd get square root of 6 over 4 minus square root of 2 over 4, which you can combine into one beautiful fraction. It's nothing nice about it, okay? This is off your worksheet. There's one on your notes here. It's cosine of 375. You have to find something on the unit circle that adds or subtracts to that number. So 330 plus 45 would make 375. And it was cosine A plus B, so they expanded it, substituted in the values, simplified, and got this answer. All right, we're going to do one rather than mess around with theirs. Okay, cosine of negative 15. I need two numbers that add or subtract to negative 15 from our unit circle, not any numbers anywhere. Okay, 30 minus 45 would work. There are others that would work, okay? Now, underneath this, I'm going to write out the rule for this time because it's the first time we're doing it. Eventually, I'm just going to assume you know where to find it. The rule says cosine A, cosine B, plus sine A, sine B. Did I copy the right one, guys? All right. So what are we going to put in everywhere that there's an A? 30. So this will become cosine of 30. This will become sine of 30. And everywhere that there's a B, we're going to put 45. So this will be cosine of 45 plus sine of 45. Okay. Did I lose anybody yet? Flip your blue sheet over. What is the cosine at 30 degrees? The cosine is square root of 3 over 2, right? The cosine at 45 is square root of 2 over 2. The sine at 30 and the sign at 45. Right? Multiplication before addition. Can we combine things when they're under the radicals? So we get square root of 6. And when we're multiplying, what do we do with the denominators? Multiply them, right? 2 times 2 is 4. Don't add the top and keep the bottom. That's when you're adding and subtracting. This is multiplying. Okay? 1 times square root of 2 is just square root of 2. In the denominator, 2 times 2 is 4. We could simplify this a tiny bit, maybe by putting it all over 4, but there's nothing else to be done. Yeah, that's a great question. This is a standard that I'm supposed to teach and I'm supposed to assess, but I'm going to be real honest and tell you that I did not put this on a test or quiz, these kind where you get these funky answers, okay? I'll show you in a few minutes the kinds that I did put on the quiz. But I'm going to make you practice it. Okay. This one, tangent is a little painful. Okay, so you want to do 60 minus 45, that will work. 45 minus 30 would work. Okay, all kinds of things would work. The problem here is that tangent gets ugly fast, okay? So I'm going to write the rule down again for this one. A minus B says what on your paper? Yep, I totally wrote it wrong. Tan A minus tan B all over 1 plus tangent A times tangent B. All right. So kind of miserable, and there's no good way of doing this. If I put the A and the B in, I get the tangent of 60 degrees minus the tangent of 45 degrees all over 1 plus the tangent of 60 degrees times the tangent of 45 degrees. I don't know what I'm writing. Okay, I know one of those is nice. Tangent of 60, if I go to 60 degrees and I put the y over the x, I get what? One over square root of 3 or square root of 3 over 3. Is everybody okay? I'm at 60. Yep, you just... Oh. Everybody else did like 45 minus 30 today, and I think yours might turn out better. We'll see. This is square root of 3 minus the tangent of 45, which is what? Over 1 plus square root of 3 times 1. No. So this is square root of 3 minus 1 over 1 plus square root of 3 or square root of 3 plus 1. It's still not done, but it's better than what they did earlier today. We can't have a radical in the denominator. Do you remember how to get rid of it, though, when it's a sum or difference? The conjugate. Good job, good job. I heard several of you. So what would the conjugate of the denominator be? Yes, square root of 3 minus 1, or however order you want to do that in. Okay, I'm going to show all of my little steps here. Square root of 3 times square root of 3 is 3. Square root of 3 times negative 1 is a negative square root of 3. Negative 1 times square root of 3 is another negative square root of 3. Negative 1 times negative 1 is plus 1. In the denominator, square root of 3 times square root of 3 is 3. Square root of 3 times negative 1. Square root of 3 times positive 1. And a negative 1. So the good news was down in the denominator, we just got a 2. Everybody okay? What did we get in the numerator? 4 minus 2 square roots of 3. Yeah, we can simplify. It'll be 2 minus the square root of 3. It isn't nice either way. The way we had to do earlier, we had to one extra step where we had to multiply through by a 3 top and bottom to get rid of denominators. It's the same answer though. Everybody's okay with how this reduced? It only reduces because they're both divisible by 2, right? We can't cancel. All right. I do hereby solemnly swear that's not on a test or quiz, okay? All right. I don't really want to do these, but we're going to anyway. Okay. You could do these in radians or degrees. You get the same answer, okay? So for most of you, you'd rather do it in degrees. I'm just going to show you that it works the same. So what's 11 times 180 divided by 12? I think it's 165 maybe. Anybody change that to degrees? 165, okay. So how could we make a 165 by adding and subtracting something that's on our unit circle? $120 plus 45, would that work? It's got to be two numbers that are on the unit circle, okay? Now, can you give me those in radians real quick just to prove to you that's the same difference? What's 120 in radians? And 45? Okay. Can you type 2/3 plus 1/4? It's 11/12, right? So it's the same difference. Okay. So I'm going to write it out in radians just because that's what we're supposed to be doing. It doesn't matter if you write it out in degrees, okay? It is cosine and it's a plus. So the rule says cosine minus sine. You can write these in degrees, you'll get the same answer. Okay, what's the next step? Yeah, evaluate those. What is the cosine at 2 pi over 3? Okay, at pi over 4, it's square root of 2 over 2. Sine at 2 pi over 3 is square root of 3 over 2. Sine is square root of 2 over 2 at pi over 4. Okay, can you simplify that at all? What are you going to get? Yeah, I did over 2 earlier and went on and did another problem before I realized it's supposed to be over 4. Now, there's really no way to simplify that. You could take the negative out, put it on the bottom instead, and the top would have a positive square root of 2 plus square root of 6. It's just messy. Okay, if I help you find the numbers, can you try this one? What is 7 pi over 12, first of all? Negative 105. What do you want to do to get a negative 105? What do you want to do? Not going to be 105. You could do negative. We don't know 15. It's not on our unit circle. You could do a negative something, but how about 135? Is 135 on our unit circle? 135 minus 30 would be, oh, the other way around. Yep, try again, Hofbauer. 30 minus 135 would be negative 105. Does that work? Okay, do you want to just do it in degrees this time since? Okay. So cosine A minus B. You guys work on it. All right, that's what I got. Anybody? You kind of get the idea that those numbers show up a lot. By the way, these work if you wanted to prove like the cosine of 30 is the cosine of 90 minus 60. It would work, okay? All right, I'm going to move on and talk about what will be on a quiz. Is a question like kind of like this. I might do different numbers, but all I'm really quizzing you on is familiarity with the blue sheet. Okay? It says tangent of 32 plus tangent of 13 over 1 minus tangent of 32 times tangent of 13. You go to the blue sheet and you go, oh, if it has a plus up here and a minus down here, that must be tangent of A plus B. Everybody find it? And what are A and B according to this example right here? So you put in 32 and 13 and you get the tangent of 45. Okay? Or this one happens to simplify. Tangent of 45 is 1. Okay? A lot of times on the quiz, I'll do numbers that don't even simplify. So at the end, you end up with tangent of 47. Just because then you don't feel the need to do something with it. Okay? You can just leave it. All right. This one might be the one. No, this one is not too cruel. Can you find sine minus cosine? Oh, maybe it is cruel. Yes, it is cruel. There's not one that says sine minus cosine, right? Yeah, so if we were to factor out a negative right now, this would be a positive cosine, and a negative sine. Okay, what is cosine minus sine? Oh, cosine A plus B, is that right? So it's a negative out in front and a cosine of an x plus a 3x, which is, okay, that was kind of icky, but definitely kind of icky because of the negative thing. All right, so we're going to try these. I don't think you have this one either, so just humor me for a minute. Find one that says cosine plus sine. Cosine of A minus B, okay? And our numbers are 7/8 pi and 5/24 pi, okay? I'd like to think you could all get a common denominator and subtract, but feel free to use your calculator. 7/8 minus 5/24. If I made this 21/24, it would be 16/24, which reduces by 8 to 2/3. Is that what you got on the calculator, guys? Which does simplify. It's like negative 1/2, yes? I don't care which you give. I'm not sure what the back of the book says. I think it does both, but I'm not positive. All right, moving on. Okay, this is one I would put on a test or quiz for sure because you can't really simplify. You can't solve this, so you will be less confused, hopefully. Can you find one that says tan minus tan over 1 plus tan? A minus B, okay. If I put in, what are A and B? Okay. All right, now I want you to look on your blue sheet and tell me what happens when you have a negative inside a tangent. It's on there. It's an odd function. It goes out in front. Did you find it? Should say right on there. Yes, it says tan negative theta equals negative tan theta. Okay. All right. Some easy ones. Sine, cosine plus cosine sine. Sine, cosine plus cosine sine. Okay, so this becomes sine of 30 degrees, or the sine, anybody do it without looking? Sine at 30. Okay. If you're at 30, you're right here. Okay. Did you go up more or out more? So square root of 3 over 2 and up only 1/2, right? Because this is longer than this. Okay. Tangent plus tangent, a plus b. Okay, so I need pi over 9 plus 5 pi over 36. This is 436 plus 536 is 936, which is pi over 4. Or that simplifies, you should know that one. 1. You could handle those on a test or quiz. Yes, that's a great question. I would like your answer to still be in radians. Most of the time, you'll probably end up with something goofy like tangent pi over 9, just because then you're not confused. Do I need to look it up and simplify? Okay. But if it was tangent pi over 4, just leave it and then write, if you want to write or 1, but you don't have to, because it just says simplify. It says do not evaluate. Okay. It says just simplify. All right. What about this one? Cosine, cosine minus sine, sine. Oh, we have to add, which is 0, isn't it? But you can leave it cosine of 90. All right. Oh. Sine, cosine, sine, cosine. Is there one that says sine, cosine minus sine, cosine? Okay. There is, because, look, A, B, yes? So if we switch this around, because it's supposed to be, can we switch it around? Why? Yeah, multiplication we can do in any order, right? So now we have A, B, and what is sine, cosine minus cosine, sine? So we would write sine of pi over 12 minus y and be done. That one was tricky just because they were trying to trick us and write it in the wrong order, but we can multiply in any order. Okay. The next thing we have are verify questions. And these are actually some of my favorite verify questions because they're pretty straightforward, just like we've been doing. Okay, there's not like 15 different ways to do them like some of them. All right, let's try this one. What we're going to do is we're going to treat this like a sign difference formula. So we're going to expand it using sine of a minus b. What would it say if we expanded it using sine of a minus b? Okay. And a is pi. And cosine of b, which is x, minus. Everybody knows I'm not distributing, right? Or anything crazy. I'm using the sheet. Cosine of a, which is pi, times sine of b, which is an x. Okay? So I traded the left-hand side out. Now what can I do? Yes. Using my unit circle, the sine of pi is, okay, but I'm going to go ahead and write it out because I'm supposed to be showing my steps to verify. Cosine at pi, okay. 0 times cosine is 0, minus -1 times sine is +1 sine. Does that equal the right-hand side up here? That wasn't such a bad verify, right? Okay, can you try this one? Just use theta. So the rule, did I write it out right, guys? Did you get sine 270 cosine theta plus cosine 270 sine theta? Okay. Then we look for 270, and the sine is and the cosine is 0. I would not require that you write that extra step in there, but it's said plus here. Is that what you're, okay. If it says minus, you can actually use either one because you could use, like, you could say B is actually negative something, but it's easier just to use whichever one it is. Okay. So like on this one, it said minus, so we use sine A minus B. Does that help? Like here, we're going to use cosine A minus B and sine A minus B. Yep. No. Okay. This is solve, not verify. It turns out pretty in the end, but it's going to be kind of painful to get there. We need to expand this, and I'm going to do it in blue. And we need to expand this, and I'm going to do it in red, okay? We can do this. Okay, cosine A minus B is cosine times cosine plus sine times sine. Okay, that all came from this one. Then there's a big minus in the middle, and I'll deal with that in a minute. But if I expand this red one, sine A minus B is sine times cosine minus cosine times sine, right? So this is A and this is B, and this one was A and this one was B. All right, how many terms are there on the left-hand side? 4 terms, right? If I distribute this negative, this will become positive, and then I have a negative on this thing and a positive back here. Now, do any of them cancel out? I don't think any of them are exactly the same. I have a cosine cosine, a sine sine, a sine cosine, and a cosine sine where there's different. Nothing's canceling out yet. It'll get better, I promise. What's the cosine of pi over 4? What's the sine? The sine is again square root of 2 over 2. And the cosine back here is square root of 2 over 2. Now did something finally go away? Those add up to be 0. Square root of 2 over 2 cosine of x and negative square root of 2 over 2 cosine of x. This is exactly the same, right? When you have exactly 2 of something being added together, don't you just have 2 of them? So we have 2 of these. We're not actually distributing, we're just multiplying, right? Because there's no plus or minus. So what happens? These 2's go away. Oh, if we divide both sides by square root of 2, we have the sine equals, what do we get over here? Can you tell me in the interval 0 to 2 pi where that's true? Okay, they get a little better, I promise. Okay, look at this one. This is the same as this. So I get what? Oh, Sarah wants us to divide by the 2 right away. Okay, we still got to expand, but it's much better looking than it was a minute ago, right? Sine of A plus B is what? And pi is kind of nice because one of those is 0, yes? Sine is 0, but the cosine is -1. So 0 times cosine is just 0, right? This goes away. -1 times sine is negative, whoops, let's try something other than yellow. Negative sine x equals 1/2, which means the sine is -1/2, which happens exactly twice. That one wasn't horrible. Okay, do we have horrible or not horrible on the next one? Oh, it's tangent? Okay. So we have 2 tangent pi minus x equals -2. So if we divide by the 2, we get tangent pi minus x equals -1. Okay. So we have A and B. Tan A minus B is tangent of A minus tangent of B all over 1 plus tangent of A times tangent of B. Okay, something good is going to happen. The tangent at pi, the ordered pair at pi is -1, 0. So when we put 0 over -1, the tangent is 0. So this is 0 and this is 0. So this whole thing is gone, right? Because 0 times that. Huh. We get a negative tangent on the top. What's on the bottom? 1 plus 0 times tangent is 0. 1 plus 0 is 1. So we just have this. If we divide both sides by -1, we get the tangent of x is +1, which happens at You can try the last one. Don't cry. No crying in pre-calc. We have to say this every day. I've already messed up, so don't worry. Good, bad, anything? Something does cancel, right? This and this are the same. And the other good news is these are also the same, yes? So we have 2 of those. Yeah, we could divide by 2 now or later, doesn't matter, because what is this going to become? If we put a value in there for that, 1/2, yeah. So it's 2 times the sine of x times a 1/2. So at some point, whether you divide and then multiply, divide, simplifies to the sine is 1, which only happens at I don't think there's necessarily any of these long, nasty equation solving ones on the quiz either. We will use more for equation solving more the ones we're going to do tomorrow, which is double angles. Okay, so you need to work on this assignment and the peach sheet, because the homework check is already Wednesday. Did anybody work on the peach sheet and have a question?